be looking at electric fields and electric field lines. This is just going to be a very theory based video, and in the next video we will be looking at electric field strength, how we can calculate it. So let's start. So a electric field is a region in space where one charge experiences a force from another charge. So if another charge, either positive or negative, ever comes close to this area around this charge, then it will feel a repulsion or an attraction force. So electric field lines are just the specific lines that make up the electric field. So electric field lines, the more they're closer together, the stronger they are, and the further apart they are, the weaker they are. So when we draw electric field lines for a negative charge, it will always have an arrow position towards it. For positive charges, then it's outwards. This is because a charge begins at the positive charge and then ends or terminates at the negative charge by convention. So these electric field lines are really important or vital when it comes to us really visualizing the vector properties and the vector forms and the vector nature of this electric field. So now let's look at how different charges are drawn. So let's start with the positive charge. So this would be a positive charge because the electric field lines are facing outwards. And this would be a negative charge because the the electric field lines are positioned inwards. So why don't you guys take a look at this and guess what kind of charged particles these are? If you said positive, then you're correct. Positive charges always repel each other. Take a look at this and guess what kind of lines they are. If you said negative, then you're correct. Negative charges always repel each other. So take a look at this new graph that I just drew. Guess which one is positive and which one is negative, and then describe their relationship. If you said this one is negative and this one is positive, then you're correct. And the relationship between this is this particular field line starts at the positive axis and then finish at the negative axis. Now take a look at this graph. We have two parallel plates with different or opposite charges. In this case, the field lines will just be parallel with each other and then travel from the positive to the negative side. So now let's look at the different properties of field lines. Okay, so the first property that we all should be familiar with is that they never cross each other. So another property that we all should be familiar with is they begin at the positive, then end at the negative charge. The third property is that they are always perpendicular to the surface of the charged body. For example, the example we looked at of the charged plate, this is the charged plate, then the electric field lines would just go upwards, making a 90-degree with the surface of the plate. The fourth property is that the closer the lines are, the stronger the electric field becomes, and vice versa. This is because the closer they are, they produce more force. So the fifth and final property is that the equally spaced electric fields indicate the field is uniform. So for example, just like the electric plates that we looked at, if the fields have an equidistance from each other, then they form a electric field that is uniform.